operating system. Now we are going to describe user accounts and groups. So let's start by defining a user account in Linux operating system. Okay, a user account is a unique identifier that allows a user to access and interact with the system. Each account has specific attributes and privileges that define the capability and the access right of the user or individual accessing the computer. We are going to look at some components of the user account. These components are what constituted to have the user account. One of them, we have the username, the password, the home directory, we have the access privilege, we have personal settings, and we have a resource usage. So we are going to look at them one after the other. When you talk about username, is a unique alphanumeric name that identifies a user in a computer. For example, you can make your computer name to be your name. Like mine, I'm called Ismail Yunus. I can put my username to be Ismail Yunus. Or I can decide for my computer name to be Ismail24. That is alphanumeric. The word alphanumeric means alphabet and numbers. Then we have a password. A password is a secret string of character used to authenticate the user and prevent unauthorized access. After you insert your username, the next thing is your password. This password it's mainly alphanumeric also, and there are ways to decide, or there are ways to create a strong password that is combining alphanumeric characters and symbols. So when you make a password to be like that, it will be a strong password. Then we have the home directory. Is a designated directory where the user personal files, configuration settings, and other data are stored. This home directory, in one single computer, you can have maybe multiple accounts, but each of these accounts will have its own directory. That means it have its designation where the personal files of that user will be stored, so that there will not be conflicts. And besides that, one user cannot access another user's account information. We are going to see it in access privileges. Alright, let's look at access privilege. This defines the user permission to access system resources, files, and commands. These privileges are typically controlled through the user group and file system permission. This is where you can give a privilege of where user A cannot access the files or the document of user B, vice versa also. So this is where access privileges work. Then we have the personal settings, that is user specific configuration, such as the desktop environment preferences. We have the terminal settings and application configuration. That is where the user will specifically make settings based on his taste, maybe in terms of arrangement of icons from the desktop, or in terms of making settings in other applications, such as, for example, maybe you have packet tracer. You make the configuration on this specific account. When you go to the other account, the configuration that you made in account A will differ from the configuration you will see in account B, because there is these are personal settings. Then we have the resource usage. This is to limit or resource consumption, such as the CPU time, memory usage, and the disk space can be set for individual users or group to ensure fair of resource allocation. Otherwise, one user can make maximum use of the resources and the other user will not have access to some of the resources. And these resources, mostly it comes in terms of memory or in terms of storage. Now look at user groups. In Linux, user groups are a collection of users which shares access privileges and resources limitation. They provide a convenient way to manage permission for multiple users with similar roles or responsibilities. For example, you can have a group for administrators, can have a group for managers, These are people that have similar responsibilities. You can group them all together in one account. Then we have primary group. Each user is assigned to a primary group upon account creation. This group determines the default group ownership of a file created for the user. Then we have the secondary group. User can be member of multiple account groups, granting them additional privileges based on the group membership. You can be in one group and at the same time be in another group. Then you have someone that is having secondary group will have extra privileges than someone that only possess in primary group. Then we have the access control group. Group membership plays a crucial role in access control mechanisms such as file system permission and network access control. Key concept in user and group management. The key concept we look at is the user ID, that is the UID. We have the group ID, the file system permission, and the root user. Then we have the sudoers. Okay, the user ID is a unique numerical identifier assigned to each user account, as we looked at earlier on. Then we also have the group ID, a unique numerical identifier that assigned to each group, which differentiate one group to another group. Then we have the file system permission. This deals with the access control to files and directories based on the users, groups, and other users. Permissions are typically defined using the chmod command. Then we have the root user, the administrator account with unrestricted access to the system. It should be used with caution due to its powerful privileges. This root user is the main administrator's account, whereby he is not restricted to any privilege. The root account administrator can have access to all facilities of the computer. So therefore, that is why it should be handled with care and caution, because once you can access the root user account, you can penetrate through all other accounts. Then the sudoers are a mechanism that allow authorized user to execute command with root privileges. So if you look at it, by efficiently managing user accounts, the group and the system administrator can ensure system security, they can control the resource usage, and they can facilitate on collaboration among other users. So the specific command and action a user can make to manage a group may vary slightly between different Linux distributed operating systems. Let's look at user authentication. A user authentication is a process of verifying the identity of a user attempting to access a Linux system. It ensures that only authorized individuals can gain access to the system resources. In this authentication process, the user provides his identity, and the system will compare the identity presented by the user with the identity that has been stored on the database. If the user identity that presented is equal to the identity that has been stored on the system, therefore it can grant access for the user. So let's look at the username and the password. The most common method user provides their unique username and secret password. The system verifies the information against its database, as I earlier said. We also have the two-factor authentication. This is an additional security mechanism that requires user to provide two forms of identification, such as, for example, password and a code generated by an authenticator machine or engine. So that's the two-factor authenticator. We have the Google Authenticator is a good example of this two-factor authenticator. From your WhatsApp, you can go on settings and set your WhatsApp to have two-factor authenticator by providing additional security to it. And making two-factor authenticator is another advanced level to protect or to secure your system from unauthorized usage. We have also public key infrastructure, which is the PKI. Utilize public key cryptography for secure authentication. User generates a pair of key, that is public and private key. The public key is shared while the private key remains secret. This allows for secure remote login with the need of password. Look at the policies that guides creation of password, how to have a strong password. Okay, a strong password policy are crucial for system security. They help prevent unauthorized access and mitigate the risk of password related breaches. Common password policies guidelines include the minimum length, of which the minimum length of a password should be 8 characters to increase its complexity. Because when you put password with minimum length of, for example, 4, it will be easily attacked using brute force attack. That is making possible combinations of characters and numbers to access a system. Then we have character requirement. Required a mix of uppercase and lowercase, numbers and special character. This makes the password to be more secured and to be more complicated by an intruder. Then we have password history. Prevent users from reusing old password. For example, there are people that have been using password for like 6 years. It's an old password. There may be chances maybe the password has been accessed by other person, and you can easily check on and try maybe using brute force attack to access your system. We have password expiration. Set regular password expiration interval to encourage user to update their password periodically. They will also have account logout. Logout account after a certain number of failed times after a certain number of failed time attempt to a data using brute force attack. Some people will just be using possible ways to see that they access a system. That is why we have these IDS, intrusion detective system. These are softwares that detect intruders maybe by the number of times they use to attempt to attack a system. So when you maybe possibly attempt maybe 5 times to access a system and it's wrongly attempted, the system will automatically denies you. Maybe it will give you an interval period of time before you can access the system back. All these are policies, or these are guidelines that will help you to set a strong password. This will reach the end of our today's class. If there is any question regarding what we have discussed, please feel free to ask your questions. Thank you very much for listening and watching. See you in the next class.